Okay. Okay, so in my second talk today, I'd like to give you, well, maybe some information about the direction where we go. And first, maybe let's have a look at the technologies that are used at Zabbix. And in one picture, this is actually the agenda. So we have some good parts in Zabbix, and we have the whole Zabbix. So, and let's try to understand what is a good in Zabbix so we can live with it, and what's maybe not so good so we can make some improvements to make it better. But first, let me remind you, and this is how I see what we are building. So I guess we are building a platform we can trust. So Zabbix, it needs to be a monitoring system that we can trust. So it basically, and a monitoring system which is not actually limited to IT monitoring. Because what is Zabbix? Zabbix is kind of a brain, how brain operates. So it just receives some information, some input from some sensors, some data, integers, strings, log files. Then it analyzes this information using triggers and then creates some output. And output could be different. Yeah, we can do whatever we want. We may use some scripts, we can alert users, we may do some automation, so everything. So actually, Zabbix is not limited to IT only. So, and the trust, it means reliable, stable, correct, and predictable monitoring system. So if Zabbix tells you, okay, we've got a problem, we must be 100% confident, okay, there is a problem. Zabbix tells you, okay, problem, there is a recovery, okay, we must be absolutely 100% confident there is no problem anymore. And also, it's related to visualization. So we go to Zabbix front end, we see something. Okay, again, we must be 100% confident that's what actually happens in our production environment. And another thing which is quite important, it's related to performance, it's related to monitoring of different environments, smaller size and maybe larger size. It's a scalability. So I'd like Zabbix to be suitable for environments of any size. And it's not only about performance, it's also about the usability of the front end. Okay, you can make front end which is nice if you have 10 servers. Okay, you have 10,000 of servers and the front end doesn't work. The solutions we built into the front end, they are not suitable anymore. Just let's go back into 1998 when I started my work on Zabbix. And initially it was, and I was a system administrator, so I was responsible for managing different big Unix boxes, HPX, AX, Solaris, as well as some database servers, Oracle, DB2, Informix, and so on. So probably I was quite lazy, so I was trying to automate my work. Yeah, do some automation, some basic stuff. So initially, kind of prototype of Zabbix was just a single Perl script. Checked to, it connected to different operating systems, checked if they are up and running, and so on. And then I was thinking, okay, Perl probably maybe it's not a good choice. Okay, it's not a good choice. So I decided to use C language for all critical parts. So the architecture was completely changed at some point. So the C language for all critical parts, server side, agent side, and later proxy side. PHP language for the web interface. And actually, in 1998, I didn't have much choice. So there was PHP language, there was Perl CGI, what else? ASP maybe. Yeah. So PHP was quite obvious choice. Yeah. And the SQL backend. So I thought, okay, round-robin databases. Also, I didn't like it because they aggregate information. And you need to set up rules of this aggregation in advance. So you need to know in advance how you'd like to aggregate your data. But then requirements may change, and you don't have access to original data anymore. So the SQL backend. And let's have a look at the properties of this stack of C, PHP, and SQL. So the C language, it's a very low-level language. If you know some programming a little bit, there is well, some binary code, there is assembly, there is a C language, which is really, really low level. Linux kernel is written in a C language. And the good thing about C language, it's very efficient. So if you're a good programmer, you can write a very, very efficient code, like Linux kernel is. Also, efficient code, well, means fast. It means it doesn't require lots of resources, means CPU resources, memory resources, any other resources of our servers. And also, it allows you to write application with almost no dependencies. Of course, you can build many dependencies if you write application in C language, but there are no dependencies. There is no dependency on an interpreter, no dependency on some kind of some different libraries and so on. There are some drawbacks as well. It's a slower development. It's low-level language, so we have to care about everything: memory management, some logs if we are dealing with some shared resources and so on. So it may slow down development because of low-level nature of the language itself. But it's a good engineering. Yeah, if you look the Kernighan, Ritchie, the authors of the C language, the language is very, very old, and it's really reliable. It's a really reliable technology. Okay, the PHP language is like a different universe. Yeah, it's absolutely different. So first of all, it's a high-level language. It's high-level language. It has, of course, some advantages. Fast learning curve, so it's easy to get started to write well, bad PHP code. Yeah, okay, you can spend maybe one day and you can start writing bad PHP code, but it requires more experience for creating a good PHP code. And same with the C and all other languages. Good thing about PHP, it's available for all platforms. So we may deploy Zabbix web frontend everywhere, Windows, Unix, well, no problem. And there are some disadvantages of a PHP. It's dynamically typed. And because of it's dynamically typed, it means that you have a variable defined in a PHP. It's array. And next line, you can turn it into integer. Next line, you can turn it into object. And it creates all sorts of problems. And because of its interpreted language, errors, warnings, different problems, they tend to come up at runtime. Okay? Maybe there is a typo, you go to Zabbix frontend, you see, okay, there's undefined variable or some syntax error, so there is no check. Yeah, so there is no kind of compilation phase when your compilator just verifies that your program is correct. Yeah, and there are some books. This is a book written in 2009. It's about PHP 6, but there is no PHP 6. There is still PHP 5.6, and the next PHP version will be PHP 7. Yeah, but you may buy this book and read about PHP 6, which will never exist. Now, SQL backend. Well, SQL backend, you know that you may run Zabbix with MySQL, Postgres, Oracle, DB2 as a backend, and SQLite also supported on proxy side. And what SQL gives us? It's a transactional storage engine. Okay, transactional is really, really important, yeah, because we may do a massive amount of changes, and they will be all atomic, yeah? Okay, that's really, really important, and also it gives you consistency. Consistency in terms of some, well, some constraints on database level side, also different types, and actually the engine itself verifies that your data is in consistent state. And the standard API, or the SQL language, that's cool, yeah? So SQL gives you a promise. The data will be in a consistent state, and this is a language to talk to your data. That's very nice. If we compare it to NoSQL world, where you have different APIs, okay, different database engines, most of them do not guarantee, well, the transactional approach. There are no transactions, or transactions are very limited. Yeah, very limited maybe to subset of data. there are two problems. It's not that good in SQL world. That's why we have a so popular NoSQL movement. Two problems, the scalability. Okay, it's not so easy to scale SQL databases, traditional SQL databases. It's easy to scale for read operations to some extent. You need to make maybe some modification changes on application level, but not so easy for extensive write operations. So Zabbix is able to generate, I don't know, like, I don't know, tens of thousands of transactions per second, tens of thousands, maybe 100,000 of writes per second, and it's, well, it's impossible. It's impossible to scale SQL to this level of performance unless you use special techniques or special hardware. So it doesn't come out of the box. And high availability is a problem as well. So even if you take MySQL, you can do the high availability in many different ways, and there are drawbacks of each of them. Yeah. So it also doesn't come really out of the box and not so easily configurable. You always have to check if it works or not. There's master-master replication. That's fine, but it doesn't work well if you have, I don't know, your nodes in a different data center. There is a master slave, and you always have to verify that master slave is really working. Yeah, so there are some drawbacks. And let's have a look how this stack, C, PHP, and SQL affected Zabbix. Well, Zabbix, I believe you'll agree, is a super compact application. Yeah. So if you have a look, I just compiled it 1 hour ago. Zabbix, and Zabbix server is a little bit more than, it's just a, Zabbix server just a single binary, okay? That's cool, yeah? And the size of the binary is 1 meg, a little bit of than 1 megabyte. Zabbix agent, again, it's a small binary, and the size is very, very small. And there are a number of consequences. One is it's really easy to maintain Zabbix, okay? You want to upgrade Zabbix, what you need to do, just install a new binary file, okay? So it's very easy. Another thing, an advantage is that, again, there are almost no dependencies. In order to run Zabbix agent, you don't have to install any libraries, any runtime environment, anything. Yeah, it's not like Java when you need to install a whole bunch of, well, classes, JVMs, and so on, yeah? And Zabbix server also doesn't have lots of dependencies, maybe MySQL library, NetSNMP, OpenAPMI, and maybe another few, and that's it. So, almost no dependencies, quite easy to maintain because of this. So Zabbix is quite small application, high performance because of use of a C language, so we are very close to hardware, and we can be very close to hardware. Low resource usage, supported on all Unix platforms, but of course, and it's mostly related to PHP, not really to the front end of PHP, but mostly some regressions and unfortunate issues, yeah, because of this interpreted way how PHP works. And there are some techniques, some additional techniques we use to get maybe sometimes some better performance. One is a cache, yeah? So it wasn't the case with Zabbix 1.8, for example, or yeah, on Zabbix 1.4, on Zabbix 1.0. So now we use the caching pretty extensively. So for example, we've got a configuration cache, basically a layer between the Zabbix server, Zabbix proxy, and the database. So in order to retrieve information from the database, we don't make direct calls anymore. So we are taking this configuration data from a configuration cache. We also have a value cache, which was introduced in Zabbix 2.2, and it significantly improved performance of trigger calculation. Because we don't go to the database in order to retrieve data for evaluation of triggers, like a minimum for a period of time. So this information is taken from memory, and it improves performance very, very much. And also, we have, well, so-called history write cache. So we don't write directly to the database. We are trying to do some kind of bulk operation first. And this is the second technique, so the bulk operations. So for example, instead of doing multiple inserts to the database or multiple updates to the database, we are trying to combine them and do it as a one bulk operation, and it really gives us much better performance. Okay? Unfortunately, this technique, the caching, we use only for the backend on Zabbix server and Zabbix proxy side. And the bulk operations is also only implemented on a Zabbix server and Zabbix proxy side. So what are the good parts of Zabbix architecture, I think? First of all, it's a good separation of different functions. The data collection is quite well separated from the rest. We have host, we have items, agents, and we are able to collect data without affecting anything else. So problem detection, so we've got another layer. This is our triggers. It's about kind of decision-making engine. Yeah. So basically, we have some data coming, and then we may decide if we have any problems, and we may detect those problems thanks to triggers. We have also alerting. So triggers, they generate events, and based on these events, we may create some rules to generate some well, alerts, notification, execute some commands, and so on. And then we have a front end and visualization. And then we have the API. So good separation of logic, maybe not so good like when we have API and Zabbix front end. They're quite connected, but still, I think we have a good separation of different functionality of Zabbix. Zabbix also is multi-process application. So Zabbix proxy, Zabbix server, and Zabbix agent, it's a multi-process, so it scales well to a number of cores we have. So there were some examples, some users are running 1,000 of pullers on Zabbix server side. That's fine, yeah, no problem. So if you have, I don't know, 32, 128 cores, Zabbix may scale to take advantage of your hardware. And again, thanks to SQL, the data, configuration data, and history is always in a consistent state. That's what your database gives you. Okay? The data is in a consistent state, and it's a huge advantage of SQL databases. So I believe it all was a really good foundation in 1998, and still is. But let's have a look at some of the challenges, maybe new challenges we have. And actually, it's kind of a problem because we use a different technology for backend development and for a front-end development. Backend is a C language, and the front-end is a PHP language. So sometimes we end up with a situation when we need to write duplicate code. Yeah, so this is the C code, and you see in the commands, don't forget to sync code with the PHP. We are doing some changes here, so we need to tell then PHP guys, okay, just do the similar changes in the PHP code, which is not good. This is not good at all. It creates some problems with the testing, with the quality assurance, and even the fact that we are doing exactly the same thing twice, it's absolutely not a good solution. So different technology, backend and the front end, the C and the PHP, it means we have kind of two different teams of people. One which knows C very well, another that knows PHP very well. And why there is a problem is because sometimes we are trying to solve the same problems in two different ways, yeah? On C side, on the PHP side. And also, we're just collecting the knowledge. And the knowledge base also, it's kind of separated. So there is one knowledge base for C guys and another knowledge base of the PHP guys. If we use the same technology, I guess it would be maybe more efficient. So the speed of development, a little bit of a problem just because we use two different technologies. So I cannot tell, for example, one developer, okay, please do everything. Here's a new feature, okay, do everything, server side, front-end side, and then we'll test it, commit, and that's it. Okay, we still have two kind of two teams of people that a little bit disconnected, because we have guys, they know PHP, and other guys, they know C language. Regressions and quality. We are working really hard to move, to make Zabbix, to bring more quality to Zabbix, yeah? But still, sometimes we have regressions, and in some cases, it's also due to duplication. So we do we actually write twice more code than we have to, in some cases. So high quality, of course, we can write lots of tests, get maybe 100%, 80% or 90% of coverage. Another solution maybe is to use better tools which would eliminate some big classes of big problems. Like, for example, PHP, there is dynamically typed language, and because of it's dynamically typed and it's interpreted, there is a whole bunch of problems. For example, just theoretically, if you replaced it with other technology, the whole class of problems would disappear immediately. So, and historical PHP code, yeah, so I guess this is my fault, because PHP is still not, our front end is still not an MVC application, so we don't have MVC on the front end side. Yeah, so that's not good. And the performance. So, and there is 5 things I'd like to improve in Zabbix. What's the first one?
Pretty good process.
Anything else?
Multi-scala. Data abstraction.
Multi-scala? That's a good point. Okay, anything else?
Security.
Okay, so let me start. There are many, at least 5. So, the web front end, okay? That's a quote from today's presentation, from Lucas. Navigation is not efficient. Just have a look at the menu, okay? You may use some iPad, sitting in a train, try to move from monitoring to, I don't know, to configuration. It's not that easy. There are too many clicks for basic workflow. Okay, suppose you, okay, what's the basic workflow? Okay, for example, you'd like to create item. Okay, you create item, and then you'd like to create a trigger. So very basic workflow, okay? So what you do configuration host, you create item, and then what? Then you need to go back and, I don't know, select a trigger. You just lost connection with your item. You don't remember what the item key, and it's a nightmare. And especially, okay, and finally you create an item, you create a trigger, and you want to check if it works or not. So you need now to switch to monitoring. So you go to monitoring, and then you need to remember what host was the item. Well, it's a nightmare. Okay, you know this better than I am, because I'm not a user of Zabbix, actually. Information, yes, it's also the monitoring administration is strictly separated and disconnected information, as in my example. Item, configuration of item in one place, then the monitoring, latest data, it's also item-related information. It's another place. You'd like to see some graph of this item. It might be in another place. And the drop-downs. Drop-downs, it's a big problem. Why? Drop-downs are absolutely fine for navigation if you have not so many objects, like 10 objects or 100 of objects. Okay, it's... Rich, anything to add? Okay, so another problem is the drop-downs is a memory usage. So if you have 1,000 of servers, you go to the latest data, and the drop-down needs to be displayed, and the information about 1,000 of hosts needs to be on a client side. And it creates a huge XML, or a huge HTML. It could be a few megabytes on the client side, and it will always be downloaded and generated. It's absolutely not efficient way. Performance, usability, many problems with the drop-down. So I believe we need to resolve this problem somehow. So those are just a number of facts, and that's what we need to do as soon as possible. We need to improve usability. We need to improve navigation. I'd like to see it a little bit more object-centric. So basically, you select a host, and then you one click away from a configuration of this host, one click away from some reports related to the host, and so on. So you select object, and you can do everything with this object. You selected the item. Okay, you can do everything with the item. Okay, so I guess this is a way to go. Information also needs to be interconnected, and it's related to my second point. So currently, the kind of a standard navigation way is to use the menu. So you just select one menu item, go to one place of Zabbix front end, then another menu item, you go to another place of the front end. I'd like to see that information Zabbix front end will be interconnected, so in some natural way. Yeah, now it's not connected in a natural way. And make it faster. You remember maybe these problems with the latest data, performance of latest data, when we did some performance improvements everywhere except the latest data. So latest data became much slower in one of the early versions of Zabbix 2.2. But it's not only about the latest data. We have also other pages where some performance improvements are really needed. Okay, the second, API. So API can be extremely slow, especially when it comes to operations related to template linkage. Okay, suppose you have 10,000 of hosts. You'd like to, well, link, or you'd like to make some mass updates, or link 10,000 of hosts to a single template, and it will take ages. So it may take, I don't know, maybe some of you tried, but it may take maybe, well, 10 minutes or 20 minutes. It depends on your hardware. It will generate so much SQL queries, maybe even millions of SQL queries. So and the reason why, because we don't use this optimization technique. We don't use cache, and we don't use bulk operations on the front-end side. So this is a big problem. We have also no strict validation at the API side, and quite weak error reporting. Okay? So you do something, okay, you made some mistake, maybe a typo in your API call, and then API call will return you some generic error, so you'll never know what really happened on API side. So that's what needs to be done. We need to make it 10, 100 times faster. So bulk operations, more efficient algorithms, I think it's absolutely possible, absolutely. We need to make it first-class citizen. Now, API is kind of part of the front end. It's not like maybe a separate entity which we take care of. Yeah, and possibly one of the possible solutions is to move to the Zabbix server side. Okay, not to make it independent, the kind of PHP application, but move it to Zabbix server side. If Zabbix server runs, you have Zabbix API available, and it will give you very nice advantages. So the strict validation is absolutely must. Error reporting and possibly composability. It's just some ideas, so you can maybe execute multiple API calls within one request. It will be executed as a one transaction. Okay, so that might be very nice to have. Another problem is the reporting. Okay, we have so much value in information collected by Zabbix. Okay, it's everything. Events, information about problems, we have a history, we have a trends. So everything in the Zabbix database, but we present this information badly. Yeah, we don't present it in a good way. We can do we can do it in a much better way. So we have really quite limited reporting capabilities, no analytics, not so well. no way to create ad hoc reports, no way to memorize parameters of executed reports. So now you're just selecting some host groups, you're executing a report, but then in order to rerun this report, you need to make it over and over again. Again, select host groups, select some parameters, time periods, and run this report. And this time, there are so many visualization tools available around. So, and it's a crime not to use them, really. Things like some reporting about event correlation, some long-term reporting, visualization, it really gives you insight of your data or your big data if you're collecting, I don't know, terabytes of information. So we really need to build it into Zabbix frontend and make it essential part of the front end. So this is really, really important, and I guess all of us miss this feature very, very much. Of course, we don't know. At this moment, I don't know what kind of tools we are going to use and how this will be implemented, but this is where your feedback is really, really important for us. Just tell us, register some feature requests, vote on the feature requests, what reports are the most important for us as Zabbix users. And the scalability. Zabbix becomes slower as data volume grows. What happens normally? You just install Zabbix server, MySQL with some default parameters, or maybe not default parameters, even highly tuned MySQL, and at some point, and it works fine. Okay, it works fine. Maybe well, 1 month, 2 months, 6 months, and then everything becomes very, very slow. You just run VM stat, and you see IO weight 50% or maybe up to 100%. Yeah, because it's data and the indexes, it doesn't fit memory. You have a huge table, so hundreds kilobytes of history and trends, and it becomes very, very slow. And in order to make SQL databases to scale, you need to do some special techniques, and you know about this. For example, you may use the database partitioning. And database partitioning is not part of Zabbix application, so you have to use external scripts, and it requires some extra steps. So not all users are quite confident to run database partitioning just because it's not part of Zabbix application, and it's not something that we kind of officially support. It's not in our code base. And also, it's not easy to deliver high availability and redundancy for massive amounts of information. So if you are talking about the terabytes, it's a challenge. It's a challenge to deliver high availability and redundancy. It's not easy anymore. So you need, again, to use maybe some special techniques. And this is where horizontal scalability of NoSQL storages may help us very, very much. So, and the idea is to have a separate storage for historical data. Okay? So we need consistency, and consistency is a must for configuration data and, of course, for historical data as well. But still, I think it might be a good idea, so we split, okay, you may have all configuration data in SQL database, MySQL, Postgres, Oracle, whatever, and history in a separate storage. Could be anything, Cassandra, I don't know, InfluxDB, MemSQL, Redis, well, you name it. Also, we need to start thinking about the next generation distributed monitoring. There are many, many ideas floating around, and it also may contribute to the scalability, because if we have a distributed setup, it basically means we don't have maybe kind of single failure of single point of failure and single point of where all information, all our terabytes are collected. But still, it's very nice to have a horizontal scalability on a storage engine. And front-end performance is important. It is really important. Of course, we can scale to terabytes. It means that we may store terabytes of information, but another challenge is to process this data. Okay, you go to Zabbix, you want to see some report, and actually you'd like this report to be generated very, very fast. Another thing which is really missing in Zabbix is encryption. Okay, yeah, so it's been for years. Yeah, it's I guess one of the, yes, maybe it's #1 or #2 feature request in our tracker. So encryption authentication are not supported out of the box. It's a shame. Of course, it can be implemented by third-party tools. I don't know, S-Tunnel, OpenVPN, some other solution. But again, it's not well integrated into Zabbix, and it's kind of a challenge to maintain it, especially if you have if you have a larger environments and a very distributed environment. So it's a challenge. It needs to be part of the product. So encryption, authentication must be part of the product, and it also must be easy to enable and maintain. Okay, because sometimes encryption is a challenge. You need to generate some certificates, some keys. There are some long procedures how to do it. It needs to be done so that you install Zabbix and it comes with the secure communication out of the box. Still, I'm personally not quite sure about public key encryption between for the agents. I'm not sure what kind of overhead it will introduce. Yeah, because the communication with agent is quite extensive, and if we start to do lots of handshaking, lots of encryption, lots of encryption-related thing, it may reduce performance, and especially on Zabbix server side and busy Zabbix proxy side. So still not sure. It just requires a little bit of testing and a little bit of experience. So we need to implement something and then see if it's okay or not. So and of course, those are only 5 things. Those are the major things I see that really needs to be improved in Zabbix. Yeah? You can name maybe tens or maybe hundreds of other different parts that needs to be improved. And if you look at our Zabbix Next issues, you may see many of them. If you ask me if I am satisfied with existing tools and design decisions, well, my answer is probably not quite. Yeah, so not quite. And especially remember the situation with the distributed monitoring, node-based distributed monitoring. So it was designed some time ago, and at that point of time, we made, and I made a number of bad decisions regarding the design of the node-based distributed monitoring. That's why now we made quite difficult decision to remove it. So we don't support node distributed monitoring anymore. So I don't really want this mistake to happen once again. So now, and actually I prefer to spend more time thinking about the good design rather than run and start coding. Yeah? So that's why maybe you can see that some feature requests are not implemented, maybe sometimes even for years. It's not because maybe we don't know how to do it quickly. Maybe it's because we don't know how to integrate it nicely into existing infrastructure. We don't know how to make it kind of essential and natural part of Zabbix software. So that's really important. The good design is really important. And you may also ask what changes we may expect in the Zabbix 3.0, which is scheduled to be released in May next year. And honestly, I don't know. So I don't know. I'm not happy about making any promises. So I made so many promises, which, well, not anymore. One thing I'd like to say is that we really are doing all our best to build a good product. Yeah. Sometimes maybe we don't have much resources, or sometimes we cannot come up with a good design. Sometimes we are delaying things, but still we are trying to build a better product with each major or a minor release. Okay, thank you very much. Any questions?
I have a question about encryption and authentication. Have you thought about persistent connection between agent and servers? Because if there was encryption enabled, the handshake take some time and resources.
Yeah, it's absolutely possible, but it will require a little bit of some quite significant design changes on Zabbix server side and the way how we do the scheduling for the checks for pulling, because now you may start a number of pullers, and those pullers may retrieve information from your agent in a parallel. So if we introduce persistent check, there are some technical difficulties. So there must be some maybe heartbeat messages, or we need to check if this connection is still alive or not. So the whole new level of some issues to resolve. But yes, of course, we will consider this idea as well.
Thank you.
Okay.
And kind of a suggestion is that please don't implement your security libraries yourselves. Please try and use external libraries that are already out there, that are well tested, that are well hardened, rather than doing what other people have done, and that's implement SSL themselves and end up having huge security vulnerabilities because of a poorly implemented library. So please try and use these external libraries that are already there much more.
Yeah, and actually, yeah, I'd like to tell you that we already made initial research on what kind of libraries are out there. Yeah, so there is no way we are going to invent our own, I don't know, encryption algorithms. No, not at all.
What do you think about monthly technical meetings in IC channels, or maybe in a web conference meetings? So we are all involved in technical procedures of Zabbix. So we are all interested in technical visions. So can you share these knowledges monthly in IC channels, in web conference?
Well, you're thinking about more kind of some kind of progress report or our thoughts, what we are doing.
It's not a report, it's like a conference, 2 hours maybe conference, like a Linux kernel conference, like a proxy conference. So distributed ISC channels, or maybe a web conference in Skype, in other channels. So to involve the other technicians all over the world to improve your server side. So it's like a deep analysis of what we can do now. What are the next steps? Because many of us don't live in Riga. Yeah. What do you think about this idea?
Yeah, I guess it's a good point, but also another thing. Yeah, I absolutely agree with you. Another thing we need to improve as a Zabbix, it's to improve kind of a visibility of our development process, because we have quite a strict development process now. So we create specifications, we review those specifications. Actually, all the specifications, all development work we are doing, they have specifications ready, with some exceptions. And this is, I believe, the way how we also may involve Zabbix users and a community. So they can review specifications and tell, okay, you are doing this right, or you are doing this wrong. But we do not advertise it loudly right now. So I guess we really need to improve it, to make it more visible.
Can we help you to do this?
I guess that's a problem we need to solve. Yeah, that's
your problem is our problem, yeah? Well, friends.
Okay, I agree. Well, absolutely agree. Okay. Yeah, we can do it. We can do it. Thanks.
I have 2 questions, in fact. So the release date for 3.0 is not so far. So when are you? Which date are you confident for the roadmap of 3.0? I mean, what will be included in the roadmap, and when will it be published? That's the first question. The second question is that you are maintaining right now many branches. So 1.8, 2.0, 2.2, and so on.
Yeah.
Is it not too much for Zabbix to maintain so many branches?
Okay, yeah, so yeah, some time ago we introduced some LTS releases, long-term support, and we do provide 5 years commercial support and just a general support of our distributions. So LTS is 1.8, and 1.8 will not be supported starting from the next year. So we don't have to maintain 1.8 anymore. So we have Zabbix 2.0, 2.2, and 2.4. So basically now we are taking care of 3 releases only. And 2.4 is not LTS release. So it will be supported only till Zabbix 3.0. So there will be 3 major releases to support. But it's absolutely required for our customers. Yeah, because some customers are not happy to make frequent upgrades. So they want a stable solution to run for years, like 3 years or maybe 4 years. So that's what we need to do. And regarding your first question about the roadmap for Zabbix 3.0, we already started our work on the roadmap, and actually you all can also affected by sponsored development or by voting on the feature request. I think it will be published at some point before, I guess, maybe before November or mid-November, just as the first draft of the roadmap for Zabbix 3.0. But as you see, some development work, for example, encryption, it's mostly server-side. The scalability is mostly the server-side. We have lots of work on the front-end side related to visualization and reporting and API. Probably will move API from PHP to C. Yes, it's a huge amount of work. So that's why I cannot guarantee that it's all will be implemented in 3.0. It's just a kind of a general direction where we are going.
2 years ago, if I recall correctly, you were talking about the aim of making your front end basically an application communicating via the API with the server. And this would basically allow any of us to develop their own front ends, and there would be no situation in which your front end is in any way privileged to the other, because underneath it would be all API calls. And I was wondering, since you're talking about switching the API down to Zabbix server, is this goal still in your roadmap?
Absolutely. And actually this is one of the reasons why I would like this clear separation of API and API code from the front end. Because really API is a little bit front-end centric, our front-end centric. So we miss something in API, okay, let's do it on API side, not on the front-end side. And actually this is one of the reasons why I would like to make it kind of independent product. So this is Zabbix, Zabbix server, and it gives you, exposes the API to all front ends, including Zabbix front end. So there will be no kind of privileged state for Zabbix front end. It's just one of front ends. And actually, all mobile front ends that exist nowadays, iPhone, Android, I don't know what else, on BlackBerry, they all already built on top of Zabbix API.